We've looked at graphing rational functions before. What we're going to look at today is how to incorporate limits. So quick review. Y equals x over 4 minus x squared. We start by factoring the denominator. We find x and y-intercept. X-intercept comes from letting the top of the function equal 0, so that'll be x equals 0. Y-intercept, if you let all your x's equal 0, you can solve it that way. Or a quicker way to get your answer, if the x-intercept is 0, the y must also be 0. Vertical asymptote, what would make your denominator equal 0? That's what we're not allowed to divide by. So 2 or negative 2. And the horizontal asymptote. We had 3 rules before that we had to memorize, and we might have forgotten them. So the good news is now we can just do one thing every single time. The one thing we're going to do is calculate the limit as x approaches infinity. Here's why. Imagine we've got a graph. It's got a horizontal asymptote. And let's say the graph looks like that and like that. The horizontal asymptote is what your graph is approaching as x gets very large in the positive or negative direction. So if we calculate the limit as we approach infinity, it should tell us what the asymptote is. So let's try it. Approaching infinity, we have a fraction. If we divide by the highest power of x taken from the denominator, that should solve this one. So we divide everything by x squared. Let's reduce that. We get 1 over x for that one. This would reduce to 1. And then putting in infinity, 1 over a very large number. If you wrote my infinite test and got 1 right, your average is not very good. 4 over a very large number, also 0. So the limit as x approaches infinity is 0, and that is the horizontal asymptote. As your x gets very, very large, your graph is going to approach 0, and that's why it's the horizontal asymptote. Let's talk about how the limits come in. X approaching 2 from the right. I have a little number line here so we can see what we're doing. 2 from the right, slightly bigger than 2, a number like 2.000001. All right, that gives us a 2 on the top. Why am I not carrying with 2 plus when it's in the top? It has no impact. 4 minus. When you square a number close to 2, it's going to be very close to 4. The question is positive or negative? Bigger than 2, 2.0001, when we square, we're going to be bigger than 4. So that'll be 4 plus. Why that matters? In the denominator, we're getting a number very close to 0. 4 minus a number close to 4 is essentially 0. But is it plus or minus? So 4 minus a number slightly bigger than 4 means you're slightly smaller than 0. When you divide 2 by a small number, you get a very big one, and it happens to be negative, so we get negative infinity. Let's try the next one. Approaching 2 from the left, so this time we're on the left-hand side of 2. The number on the left might be 1.99999. Approaching 2 from the left, we'll get a 2 on the top. 4 minus. When you square a number close to 2, it's going to be very close to 4. The question is plus or minus. Left of 2 squared would be left of 4. Check it, 1.999999 squared, you're going to find it's 3.9999 something. It'll be less than 4. So slightly smaller than 4. On the top, we still have 2. 4 minus 4 is essentially 0. Is it plus or minus? 4 minus a number smaller than 4. That means you're going to remain positive. 2 divided by a small number is infinity. Happens to be positive, so that's positive infinity. Let's keep going. Approaching negative 2 from the right-hand side. That's a number like negative 1.999. When we put that on top, we get negative 2. 4 minus a number very close to -2. When you square -2, it's very close to 4. Is it positive, plus or minus? Is it bigger or smaller than 4? When you square -1.999, it's very much like squaring 1.999. You'll stay smaller than 4. So smaller than 4. We have -2 on the top. 4 minus a number smaller than 4, very close to 0, and that would be positive. -2 divided by a tiny number is infinity, and we have one negative sign, so that's negative infinity. One more to do. Approaching -2 from the left-hand side. A number to the left of -2, -2.00000001. So -2 on the top. 4 minus. When you square -2, you're very close to 4. Bigger than 4? Smaller than 4. Which one? -2.001, when you square that, you're going to be bigger than 4, so that's 4 plus. So -2 on the top, close to 0 on the bottom. 0 plus or 0 minus? 4 minus a number bigger than 4. It's going to lead you into the negatives. -2 divided by a very small number. It's going to infinity, and is it negative or positive? 2 negative signs makes that positive. Okay, let's summarize all that. So our answers, minus infinity, infinity, minus infinity, infinity. And let me clear away the work so we can see what's happening. All right, for those who didn't like it, we'll talk about these guys later. There's another way of thinking about this. So let's try another way. 2 plus. That would be 2 plus. All we care about is positive or negative. 2 minus bigger than 2? 2 plus 2. So we know our answer is negative something. We want to look here. When you take this, can you see that 4 minus something close to 2 squared is going to be very close to 0? When you divide by 0, something close to 0, you get infinity. So all these answers where we're dividing by close to 0, the answers all have to be plus or minus infinity. So the only thing we have to figure out is if it's positive or negative. So this method, all we're doing is putting in plus signs, minus signs, and then the infinity. So let's try another one. 2 from the left. 2 is a positive number. 2 minus smaller than 2 is still positive. 2 plus 2 is positive. So our answer, positive, because we're dividing by something close to 0, infinity. Next one. -2 from the right. -2 is a negative number. 2 minus a negative number, still positive. 2 plus a number slightly smaller than -2, like 1.99999, are you positive or negative? 2 minus 1.9, still positive. We have one negative sign, we would get negative infinity. And again, why are we getting infinity? Because we're dividing by something very close to 0, and we know that gives us infinity. One more. -2 from the left-hand side of -2. A number like -2.01. -2. 2 minus a negative, that's positive. 2 plus -2.01, that'll be negative. We know our answer is infinity. We have 2 negative signs. That'll be positive infinity. So some of you might prefer to do it that way, or you can do what we showed you earlier. Now these two limits. We calculated this on the previous page when we did the horizontal asymptote. We got to this point, we said as we're approaching infinity, that went to 0. This one also goes to 0, and that's where our answer of 0 comes from. Now, if you get a number, you are going to get the same answer when you approach negative infinity. Why? Because you do the same thing. As you approach negative infinity, 1 over negative infinity is also 0. 4 over negative infinity squared is also 0. So as long as you get an answer that is a number, you'll get the exact same thing for plus or minus infinity. There'll be other situations when we don't. We'll talk about those in a bit. So here's our summary. Let's see if we can draw the graph. I'll draw my usual rough one. X-intercept, y-intercept 0. Horizontal asymptote at 0. Vertical asymptote plus or minus 2. Okay, what does our graph look like? As we approach 2 from the right-hand side, so we're coming in towards 2 from the right-hand side, our graph goes to minus infinity. As we approach 2 from the left-hand side, our graph goes to positive infinity. We had an x-intercept of 0, so we have to pass through there. There's only one x-intercept, so no bounce, so we're expecting it to come through. We're then approaching negative 2 from the right, so this is the right-hand side of negative 2. As we do that, we're going down to negative infinity. Approaching negative 2 from the left-hand side, we're supposed to go to positive infinity. So having the limits definitely helps us draw the graph. As we go to infinity, we're supposed to approach 0. And as we approach negative infinity, we're supposed to approach 0. Much better looking graph is this one. It'll flatten out a bit there. That's lovely. I would still accept this. All we're really looking for is, are your asymptotes right? Did you cross in the right place? And again, you are allowed to cross a horizontal asymptote. Why are you allowed to do that? The asymptote tells you what the graph is doing when x goes close to infinity and close to negative infinity. It doesn't tell you what's happening in here. So that's why we're allowed to cross horizontal asymptotes. Okay, let's do another one from the very beginning. We're going to sketch y equals x cubed minus x squared minus 2x over x squared plus 1. We start by factoring. We can keep factoring. Let's find the x-intercepts. What would make the numerator equal 0? I've got 0, 2, and negative 1. The y-intercept, let all your x's equal 0. We've got 0, and we knew that because if your x-intercept is 0, your y is 0. Vertical asymptote. Is there anything you can put in here that'll make the number in the bottom 0? Nope. Horizontal, we're going to calculate the limit as x approaches infinity. We have a fraction. Let's divide by the highest power taken from the denominator. Let's reduce that. That would leave us with x. This will leave us with 1. This will reduce to 2 over x. This will give us 1. As x approaches infinity, 2 over a very large number goes to 0. 1 over a very large number goes to 0. And I've told you the answer is none, so let's just back up a minute. So as you approach infinity, we'd get infinity minus 1 over infinity. So infinity. So that is definitely not a horizontal asymptote. Limits. Now, why does this one only have 2 and the other one had 6? So what you do when you complete the chart is you always approach infinity and minus infinity. Why are we doing that? Because that will tell us what the horizontal asymptotes are. The other thing you approach, your vertical asymptotes from right and left. So the reason we don't have any others is because we did not have any vertical asymptotes. All right, let's calculate this limit. We've done that one already. We said if it was a number, it's the same on both sides. What if it's not a number? Let's check what happens with this one. We do the exact same work, and now let's plug in minus infinity. This one still goes to 0. This one still goes to 0. When you plug minus infinity in for x, we get minus infinity. So be careful. This is a situation when the two limits are not the same. If it was just a number that had been 5, this would be 5. 3, 3. But infinity, it can be different. So watch out for those. Okay, let's see if we can draw the graph. Try and draw a rough sketch, and then we'll see how that compares to the actual answer. No vertical, no horizontal. Ooh, this will be interesting. X-intercept 0. X-intercept 2. X-intercept -1. Y-intercept 0. As we go to infinity, we said we're approaching infinity, so we know we have to end up going to infinity. 1 x-intercept there, so we'd have to pass through, and head to negative infinity. Okay, how does that look compared to the graph? All right, so theirs is nicer. Your job today, you're going to do 10 graphs. They take a fair bit of time, so it might actually take you a couple of days. One thing I would like to point out, how you tackle this question really depends on what you're good at. If you're good at graphing rational functions, if you can look at that and say, all right, x-intercept -3, y-intercept -3, vertical asymptote ±1, horizontal asymptote for this one is 0. You can find that by doing the limit if you're unsure. That's a number, so they'll both be 0. The graph, we can't cross in here, so it would have to look like this. Cross the asymptote would be positive up here. Cross the asymptote would be positive up here. There's our graph, we're done. You can then fill in your limits. So if you are really, really good at sketching rational functions, you can just pick up your limits from there. Approaching 1 from the right, approaching 1 from the left, approaching -1 from the right, approaching -1, sorry, got that one wrong. -1 from the right is this side, and -1 from the left is that side. So if you are very good at sketching rational functions, sketch the rational function, fill in the limit from there. If you're not very good at sketching rational functions, do your limits first. 1 from the right. We can either do 1 plus 3, that's 4. 1 squared, 1 minus 1. It's going to give us an answer close to 0 on the bottom. We're going to have to figure out if it's plus or minus. 1 from the right, bigger than 1, squared, bigger than 1. 1 minus 1, 0 plus, positive infinity. So it depends on what you're good at, whether you do the chart first and the graph from the chart, or whether you do the graph first. Or if you just want to be super careful, work out everything and then check. So your job, do those, take your time. It's going to take you a little bit of time to get used to it, but you will get better. As always, have fun.